Okay, so this is problem 10.1.55, and they say that a customer ordered 17 zingers, and zingers are placed in packages of 4, 3, or 1, and we want to know in how many different ways can this order be filled, and 20 is not the answer there. Okay, so this problem really requires a lot of methodical thought, and you have to organize how you're going to go through it, otherwise you'll get lost in trying to figure out the different combinations. So what we need to do is organize this in this way. We're going to talk about the number of one-number combinations that will get this order filled, and then we'll talk about the number of two-number combinations. So when I say one number, we're going to work within, you can have a package of 4, a package of 3, or a package of 1. So just working with one of those types of packages. So two numbers, I'm talking you can work with the 4 and the 3, or the 3 and the 1, etc., or the 4 and the 1. And then we need to talk about all three numbers together. Okay. So let's run through each of them. So if we're just going to use one of these options for packages, and remember you've got 4, 3, or 1 are how these can be filled. And you're looking for 17 packages to be filled. You can't use either the 4 or the 3 by itself, because 17 is not a multiple of either 4 or 3. So you can't fill an order of 17 by just using packages of 4 or just using packages of 3, but you can use packages of 1s. So I'm just going to write 1s there. It doesn't need apostrophe s, I guess. So 1s, and essentially you would have 17 1s. 17 1s here. So there's just one way in which you can use one of the numbers, and that's to add 17 of these one package pieces together. Okay. All right, if we go to two-number, combining two different numbers, let's start with the 4s. Okay, so if you think about just however many 4s you can get up to get close to 17, you would need 4 of them. So I could take 4 packages of 4, that would give me 16. My hair's in the way. And then I would need 1 package of 1 to get up to 17. Okay, so that's one option. Now, so that we don't get confused, let's just, you start at the largest number of 4s here, and then let's start to work backwards. If I took away one of these 4s, then I could look at combining 3 4s with a bunch of 1s. Okay, and so I'm just going to write 1s here because it doesn't really matter how many there are here. This is one way to do it. This is one way to do it. So if you take away a 4, you can make that up with 4 1s. Okay, and then let's take away another 4. So instead of having, 3 4s, now I have 2 4s, and I can make the rest of it up with 1s. Okay, and then I could have just 1 4 plus a bunch of 1s. Now I'm not combining any 3s in here because of the fact that I'm looking at two numbers at this time. And we'll look at the combinations in the 3-number slot when we talk about 4 3s and 1s together. Okay. So these are all the possible combinations of 4s with 1s to get a pack, to fill an order of 17. So let's talk about the 3s with the 1s. Now, actually, before we do that, let's talk about the 4s with the 3s. We can actually combine the 4s and the 3s because if you try, you can try it, but different combinations of 4 and 3 will not get you to 17. You can't get a 17 out of it. And so you can get to 18, you can get to... Actually, can you even get to 18? You can get to numbers around it, but you can't actually get to 17. So 4 and 3 won't combine. Okay, so let's go to 3 and 1. So we do the same process that we did with the 4s. If we took 5 3s, that would give me 15, and then I could have a couple of 1s, and that would give me 17. And then let's take away one of the 3s and add 1s in its place. So now we have 4 3s and then a bunch of 1s to make it up to 17. And then you can see where I'm going with this. I'm going to have 3 3s, take away another one of the 3s, and you add a bunch of 1s. And then 2 3s and add a bunch of 1s. And then 1 3 and add a bunch of 1s. Okay, so if we count this up, there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 different ways that we can fill this order of 17 using 2 of the package combinations. Okay, so far we have 9 here, 1 there, we have 10 total. And let's look at the 3 numbers now. Okay, so again, if I go methodically, I'm going to think about, let me just start with the largest number of 4s that I can have, and also use a 3 and some 1s, because I'm trying to look at all 3 numbers together. So I can't have 4 4s here, because that puts me at 16, and then I would have to use a 1, and I wouldn't be using a 3, and that's not using all 3 numbers, and that is also taken into account right here. So I got to stop at 12, and then if I add a 3, that gives me 15, and then I can add 2 1s to get up to 17. Okay, and then let's do our same process here. So I'm going to take away one of the 4s, and in its place, I'm going to add a 3. So I got a 4, a 4, a 3, and a 3, and then 1s to make up whatever the remainder is there. Okay, and then let's look at the combination of a 4 and a 4 with just 1 3, and then 1s to make it up. So this is the combination of 3 4s with whatever could be done, combination of 2 4s with either a couple of 3s and 1s, or 2 4s with 1 3 and 1s. And let's go down to 1 4. So if I have 1 4, I could have, I would need essentially 4 3s and then 1 1. Okay, so that's my combination of 4s with these 4 3s. Now, I can start to eliminate 3s off of this. So I could go 1 4 with a 3, a 3, a 3, and then these 3s could be made up by 1s. And then I can do that same thing, go down to 2 3s, and then 1 3. Okay, and I believe that's all of the combinations here. So if we take a look at this, this is 1, 2, 3, 4, 5, 6, and 7 combinations here. So if I add all of these together, 9 here, 1 there, 7 there, you get 17 total. And that's actually a coincidence that this 17 matches that 17. That's just a coincidence. It's not, there's nothing about it that makes it, you know, oh, it's always going to do this kind of a thing. It just happens to be that way. Okay.